All right, welcome back, geometry students. This is going to be the first lesson that we're doing for Unit 2, talking about transformations. And today we're kind of trying to summarize all that we've done with the exploration activities. So kind of like I mentioned when we were doing the exploration activities, is it doesn't need to be exact. You don't need to know all these rules in your head when we were working on those activities. But now we're putting this into actual notes and have a place to go back and look at all these things. Okay, so before we get into this, first thing I want to recommend is in your notebook, you want to keep track of all these notes and all these units that we're doing. So I'm going to have you first go to a new page, and at the top of that, make sure that you label this Unit 2 Transformations. Okay, Unit 2 Transformations. Like I said before, this unit is not going to be about trying to really solve for a variable or any measures or anything like that. It's really just about how we can change, transform, move different shapes with these rules that we have here. And hopefully we can get better at them to the point where we're really just using the rules and just understand how to change the x coordinates, how to change the y coordinates. So that's the basic idea. So notes for today, 2.1, basic transformations. Date today is either the 5th or the 6th, depending on what day you're watching this and what class you have. And then objective is want to be able to define the basic transformations, want to be able to kind of describe them in a word, and then use the rules to solve these different problems here. Okay, so first thing, if I'm looking at the word, or definition I should say, reflection, I'll scroll down here. Okay, a reflection is just when we flip an image over a line. Okay, reflection, or obviously you can think of the word reflect, kind of like a mirror. You're flipping an image, or you're creating a mirror image over some line. We call that line, not so surprisingly, the line of reflection. And basic idea is usually we do this with either the y-axis or the x-axis, and then sometimes, kind of like you saw earlier, we have this over a specific line on a graph. Okay. So the rules that we need to understand with this, and this is the meat and potatoes of our unit, is do you know how to follow these rules? If I can have these rules in one place and if I can follow them, I will always be able to solve these kinds of problems here. Okay? So first rule, if we have over the y-axis, if I have some shape, whatever, it doesn't matter, triangle, quadrilateral, pentagon, so on and so forth, what happens to the x coordinates, and then what happens to the y coordinates? So if we think about this, when we talked about this in class, when I reflect over the y-axis, I'm going to start with the x coordinates. The x coordinates, and we can say this a few different ways, I should say. X coordinates change their sign. They change their sign, and I mean the sign in front of the number. So if it's a positive number, it changes to a negative. If it's a negative number, it changes to a positive. Okay, it's still the same number, -5 to 5, 4 to -4, so on and so forth. They just change the sign. Okay, and then the y coordinates stay the same. Y coordinates stay the same. And if you need to as well, once we get done with these, if you need to put a box around these or something like that, we're going to do that because I want to make sure these stand out in your notes, and I'll explain that in just a minute. Okay, so x coordinates change their sign, y coordinates stay the same. If I'm reflecting over the x-axis, remember now that's the horizontal one. If I'm reflecting over the x-axis, it's the exact opposite. So in this case, I'm going to say the x coordinates stay the same. And then the y coordinates are the ones that change their sign here. So I'm going to say y coordinates change their sign. Again, same idea. Either positive to negative or negative to positive. All right, and then the last one here, we looked at this a little bit with y equals x. If I have that line y equals x, it's just one straight line that goes has a slope of 1 and just goes from the bottom left to the top right. If I'm reflecting over that line, the only rule that we have here is the x and y coordinates. X and y coordinates switch places. Okay, that's the only rule that we have. If I reflect over the y equals x line, x and y coordinates switch places. They don't change their signs or anything like that. Just if it was 2 comma 5, now it's 5 comma 2. Okay, that's all it really is. Okay, what I'm gonna have you do here, what I would recommend is I'm gonna have you put a box around this, or make this stand out in your notes somehow. Because what's going to happen is you guys are going to have problems that you're working on, and I either will hear it in the Zoom calls, or if we end up getting back in person, and I'm going to get the same question over and over again. You know, how do I do this reflection? Well, I'm always going to send you to the same place. What's the rule for what are we doing? We're reflecting over the y-axis. Okay, what's the rule? And you just have to be able to go to this and say, here's what I need to do. If you, like I said, if you can follow that, you should be setting yourself up well. Okay, so with that in mind, looking at this first problem here, I want you to take a sec and I want you to sketch this diagram for me. Okay, you don't need to sketch a whole 5x5 grid. I just need 0 to 5 on the x-axis, 0 to 5 on the y-axis, and then just need to plot these points here. Okay, and then we'll come back together. Okay, so hopefully you paused your video and did that. So if I'm looking at this problem here and I want to reflect this over the x-axis and then give the coordinates of that new image. Notice on our picture we don't have enough space to actually show where it's going to end up, and so this is where our rules come in, so I don't have to draw a graph every single time. So first thing I'm going to do here, I'm actually going to cancel these out. These little apostrophes on these letters are saying it means prime, or in other words it's saying A of the new image. Okay, but I'm going to start here with just A, and what I'm going to do is I'm just going to write down the original coordinates because we need to make sure we have those. So first here, if I look at A, remember x coordinate goes first, left and right first, and then up and down. So this is 2, comma 1. Okay, point B is at 5, comma 2. Point C is at 4, comma 5. And then point D here at the very end is 0, comma 5. Okay, very important that we have the original coordinates first before we start trying to figure out what they're going to be, right? Okay. And then, like I said, instead of drawing this picture or using, GeoGebra to try to show us where it's going to end up, I can just use these rules here. So we say right here, A prime, so that's showing me A of the new shape, or the reflected shape, I should say. If I go up here, I just check my rules. We say X coordinates are going to stay the same, and then Y coordinates change their sign. So right here on this first one, if I'm looking at this, X coordinate stays the same, so that's positive 2. And then Y coordinate is now, instead of positive 1, it's negative 1. Okay? And I can kind of think about where that's going to end up because that would make sense. It's still on the right side of the graph. It's just now it's going to be below the x-axis. We can continue here. X coordinate stays the same. That's positive 5. Y coordinate changes. Negative 2. C prime. X coordinate stays the same. Y coordinate changes its sign. Negative 5 now. And then last one here, D prime, or the D of the new image, is going to end up at 0. That's not going to change. And luckily that wouldn't change no matter what. And now also negative 5. Okay, and then this is what I want to circle or underline or kind of make sure I show this is the answer for this problem. And this is where the new image is going to be. So the reason we're using these rules is because it makes things a lot quicker. Instead of having to use an app, like an online app, or instead of having to draw a picture and then say, okay, here's where this would end up, all I need to do is use these rules. And so that's why it's so important that we can just kind of revert back to those. Okay? Next one here, translation. Translation was the next exploration activity that we did. Hopefully we kind of figured out that rule. The definition is fairly straightforward. It is just moving an image from one location to another. Okay, if I want to think of a word when I think of translation, all I think is moving. I'm not turning it at all. I'm not flipping it at all. I'm just moving it. Does it go up? Does it go down? Does it go left? Does it go right? Okay, so on and so forth. Okay, that's the basic idea. And if I'm translating over a vector, this is going to look a little bit different from what we've seen in our exploration activity. So translating over a vector, if I say, for instance, I want to translate over this vector, I'm going to add these two little, they're kind of like parentheses or little caret marks. I don't know how to really officially call them, but you'll see this in a lot of your problems. You'll say translate using the vector blank comma blank, and it'll always be one number, comma, another number. So in this case, I'll just use x and y. Okay, and fairly straightforward. X is how much x coordinates increase slash decrease. I'll add this over here. Okay, slash decrease. Hopefully you guys have a little bit more room than I do. But x coordinates, or I'm sorry, x, whatever number is there, like for instance positive 5 means that you would increase the x coordinates 5. Okay, and then the y coordinate, or the y point of that vector, same thing, just with the y value. So how much y coordinate, or y coordinates if it's a shape, increase slash decrease. Okay, it will increase if it's a positive number, it will decrease if it's a negative number. Okay, translating is usually fairly the most straightforward one. It's not flipping or changing or moving anything around. It's just how much do I add to the x values or subtract, how much do I add or subtract to the y values. Okay, so let's practice that a little bit. If I'm looking at this here. Okay, again, I'll give you a second. I want you to take a minute and I want you to sketch this diagram for me. And if you really want to, you can just kind of add this triangle onto the previous one that you drew. But otherwise, you need to make sure you have the y-axis and the x-axis drawn. Okay, so hopefully you paused your video and did that. So we have this triangle here, EFG, and I want to translate it using the vector 4, -2, and then as always, my answer is always going to be giving the coordinates of that new image. So I'm going to do the same thing as before. First thing I want to get in the habit of doing, especially if I'm just given the graph, is make sure you write down the actual coordinates, because otherwise we're not going to be able to use the rules, right? So if I look at this here, good practice, make sure we have this down. E is at the point -2, 1. Go over first before you go up and down. F is at the point -1, 4. And then finally G is at the point -6, 2. Okay? And again, the goal is the same. We're trying to translate here. In this case, when it says using the vector 4, -2, that doesn't mean I put that as at a point, kind of like we did on GeoGebra. What that means is it tells me how much do I add or subtract to the x values, how much do I add or subtract to the y values. So I'm going to draw arrows here. It means we now have E prime, F prime, and G prime, where those new points would be if I translated this way. And so if that first number is 4, it means I'm going 4 to the right, or in other words, I just want to add 4. So let's start with the x value here. I have -2. When I add 4 to that, hopefully we're comfortable adding and subtracting negative numbers. That's now going to be +2. Okay, need to have that down. Okay, next part here is, or the y value I should say, of the vector is -2, so that just means subtract 2. So I start at +1, I subtract 2, and now that would give me -1. Okay, that's all I'm doing with translating. How much do I add? How much do I subtract? And we'll continue that pattern. I have -1. I want to add 4 to it. So hopefully we know that is +3 now. And the next one here, I have +4. I want to subtract 2 from this using that vector. So now it's +2 when I subtract 2 from that. And then same thing with the last one, G prime, add 4 to -6. That's going to make it -2 because it's getting closer to 0. And then +2 minus 2, that's just going to give me 0. And again, this is what I want to circle. This will be my final answer. There might be some problems you work on later today where you're wanting to specifically draw the shape after it's done. There will be a few that you need to make sure you draw the shape. But in general, that's what I'm looking for, is I'm looking for the coordinates. Okay, so that's translating. And then last one here with rotation. We just did this today. Rotation, and hopefully you understand what that word means anyway, but rotation is just turning, we'll say, I'll give you a sec to write rotation down. Turning or spinning an object. Okay? And I can do that a certain amount, but I'm trying to turn or spin an object. That's all I'm doing when I'm rotating. Okay? So for example, we have 3 different kind of rotations that we're really going to focus on. First one is when we rotate 90 degrees. And notice one thing as well, hopefully that you've seen, is we could either rotate it clockwise, so going like a clock, or counterclockwise, depending on what the instructions are. So for rotating 90 degrees, we're just going to say the broad rule is we switch, let's say it this way, X and Y coordinates switch places. Okay, so that's the first step. X and Y coordinates switch places wherever they were at. But then I need to do one more thing, as hopefully we saw from our examples. And then change one of the signs. And then change one of the signs depending on the direction. Change one of the signs depending on the direction. And so this is really going to test your knowledge. This is probably one of the tougher ones. You need to understand, where does that shape, or even where does a point start out, and then where would it end up if I went clockwise or counterclockwise. So for example, if I have this here, I have my quadrant 1, 2, 3, and 4, and I have, let's just say I have a triangle right here in this first quadrant. X is going to be positive, Y is going to be positive. If I rotate 90 degrees clockwise, or going like a clock, that means I'm going to go down here, because that's going to go the same way as a clock. And so I'm going to switch my X and Y coordinates, and then I'm going to look and ask myself, in this quadrant right here, is X positive? Is X going to stay positive, or Y is going to stay positive? In this case, since it's to the right, the X coordinate would stay positive, which means my final answer, I need to make my Y coordinate negative. So that's the sign I would change. Now if we switch that around, however, if I say counterclockwise, then I need to visualize where it's going to go. So I would go to the left over here. So now it's going to end up in this quadrant. And then I ask myself that same question. If I'm over here on the top left quadrant, is that going to be when X is positive or when Y is positive? In this case, since it's above that line, above the X-axis, Y is going to be positive, which means my final answer, I need to make sure that I change the X coordinate. Okay, and it's the same for each one. So once you get one of your points done, it's the same rule for all three. Okay, that's the best way I can explain it, and that's how you're going to want to try to visualize how you change the coordinates. Okay, rotating 180 degrees, it's a little bit simpler, luckily. Rotating 180 degrees, X and Y are going to stay where they're at, but I'm just going to change the signs of the X and Y coordinates. That's all I do on rotating 180 degrees. Okay, I change the signs of the X and Y coordinates. So if we're using that same rule that we just kind of did here, if I have this triangle and I rotate it 180 degrees, this would be 90, this would be 180. So the points aren't actually going to flip. They stay where they're at, except now, instead of both of them being positive, both of them are negative. Okay, that's the only thing that you need to do with rotating 180. And we'll practice that. All right, and then last one here, rotating 270 degrees. The good news is it's the same kind of thing, or same rule. Same rule. I'll give you a sec to write that down. Rotating 270 degrees, same rule as rotating 90 degrees. And the reason for that is it just depends on the direction that you're going. So to give you the same example that we've been using, if I gave you this triangle here and I said I want you to rotate it 90 degrees clockwise, that would mean I would bring it down here into what we call the fourth quadrant. Okay, it would be on the bottom right. If I ask you instead, I want you to rotate it 270 degrees counterclockwise, well, I'm going the opposite direction, but I'm going to end up in the same place, because this would be 90, 180, and 270. And either way, you'll end up in the same place. You'll rotate it to the fourth quadrant. And then those points, or that rule, will still be the same. X and Y coordinates change, or switch places, and then you change one of the signs depending on what quadrant it ends up in. Okay? So that is the rules. So let's go with this here. Last one, let's kind of try to put this together. Given the coordinates of the following triangle, we're not going to draw a picture with this. I want to do 2 transformations on it now, from one step to the next. And I'm going to add this here. Okay. First one is I want to rotate the image 270 degrees clockwise about the origin. That will usually be what our rotations are. It's about the origin. And then I want to give the coordinates of the new image. Oh, so in this case, we actually only need to do 1. So I don't know why I have multiple over here. Okay, we'll just practice doing it once. Oh, that's why. I just realized why I threw that in. Okay, so first one here. If I'm doing 270 degrees clockwise, first thing I'm going to do when I go, and luckily these are all written down for me, so make sure that you have these written down. J is at 1, 3, K is at 2, 7, and then L is at 5, -1. So first thing I'm going to do when I start writing out my next point is I'm going to say J prime is or equals, first thing is switch them, so 3, 1 now. And notice I'm kind of leaving space in front of them just in case I need to change one of the signs. So this is where I just need to visualize where it's going to end up. So if I think here, I don't even need to visualize the whole thing, just the point J. If I have that in 1, 3, I know that's going to be somewhere up here because it's going to be in the first quadrant. And then if I go 270 degrees clockwise, I can just track that. So 90, 180, 270. I know it's going to end up somewhere up there. Okay, I don't have to get the exact spot on my picture as long as I understand it's going to be up there. So then the question is Y positive up here or is X positive up here? In this case, since it's above that line, the Y coordinate is going to be positive, which means I need to make my X coordinate negative. So right here, my X coordinate is now going to be negative. So that same rule is going to apply for all of these. I'm going to switch them, and I'm just going to make the X coordinate negative. So now with K prime, first thing I need to do is switch them. So 7, 2. And then like we already just realized with the first one, it's going to be the X coordinate. So I'm making the X coordinate, or I'm changing the sign of the X coordinate. Okay, and lastly with L, instead of 5, -1, I have -1, 5. And last step is I need to change the sign of the X coordinate. So in this case, this X coordinate was positive. I now need to erase it, or I'm sorry, it was negative. I now need to erase this so that it is positive. So this would be my final answer here. It's -3, 1, -7, 2, and then 1, 5. Okay, the reason I added this extra piece is because if you want to do it a different way, we just said rotating 270 degrees clockwise is the same thing as going 90 degrees the other direction. So if it makes more sense for you for the 90-degree rules, that's completely fine. So if I did 90 degrees counterclockwise, this is going to end up giving me the same answers. Okay, you don't need to do both, obviously. You just need to choose one of these to do, whichever one makes more sense to you. So 90 degrees counterclockwise, if I look, that's just less to track. So I know it's going to end up in that quadrant, so it's the same rules as before. Switch them. And then in this case, I know it's going to be ending up where my X coordinate is going to be negative. So I need to change that to negative. And then same rule for these as well. 2, 7 becomes 7, 2. And change the sign of the X coordinate. And then lastly here, 5, -1 becomes -1, 5. And I need to change the sign of the X coordinate. So again, these would be my final answers as well. Ends up being the same thing. So whichever one makes more sense to you, that's what I want you to use. Whether you just go 270 like normal, or you can go 90 degrees the other direction if that is simpler to you. Okay, so that is all the rules with these 3 main transformations. We'll talk about one more later on towards the end of the unit, but these are the basic 3 that we want to get down. Rest of time today, you have to work on that homework, 2.1 basic transformations. Make sure you have these notes out. Make sure you have these rules out easily accessible, because that's all you're really doing is just looking at these rules and saying, what do I do when I reflect? What do I do when I translate? What do I do when I rotate? Okay. And as always, if you have any questions, feel free to leave those in the Zoom call. All right. Thanks, guys.